Hi everyone, welcome back where we are working still in Module 1, Topic 2, Lesson 4, moved on to Activity 3, using nets to calculate surface area. The net of a solid figure is a useful tool when calculating the surface area of a solid figure. Habits of mind, model with mathematics and use appropriate tools strategically. Number 1 says to calculate the surface area of the solid figure represented by each net. So we have this right triangular prism and its net. Now, I already have this written down, but I want to kind of develop this for you. I'm going to slide my paper up so that I can kind of work through this with you. So the state of Pennsylvania gives us a formula to use to find the surface area of a triangular prism, whether it's a right triangular prism or just triangular. So it starts here with kind of the triangle, and we are going to label the sides of our triangle just so we can keep them straight. Side A, side B, and side C. And then the height of our triangle, we know goes from the base of the triangle to the highest point of the triangle. Okay, so I'm going to go over these lines in the same colors. Okay, and then if I'm going to turn this shape into a triangular prism, I'm going to extend these lines out here and here, add this rectangle. Now I'm trying to do a 3D image on a flat piece of paper. So if you can see how they've done it here, they added some dotted lines so that you could see kind of some dimension. So there would really be like a dotted line going back here, showing you that back face of the triangle and connecting over here so you could see the base that it's sitting on and then that rectangle in the back. So just like in other triangles, we have this line from the base up to the highest point, and it forms a perpendicular intersection there. So that is the height of our triangle. And then the state of Pennsylvania has given us a formula, and I'll show you that right here. So the formula is surface area is side B times the height plus, I forgot to add. So sorry. This right here is the width of our triangular prism. That's how far back the rectangle goes. So that is the width. So side B times the height plus side A times the width plus side B times the width plus side C times the width. So it's pretty easy to remember. We have to take each of the sides and multiply it by the width. And then we also measure what we really think of. They labeled it side B, and we also often think of it as the base of the triangle times the height. So if I take the dimensions that I used here and label them over here, so side A in this one happens to also be the height. So let me come back to that in a minute. So the base of the triangle is here. We see that. Side C is the long slanted line. We see that. They've numbered it back here for us. This is a very wide triangular prism, and the width is 11, so I've labeled that W. And then the other part of the triangle is this side A and the height. Well, the height of the triangle is from the base to the highest point. This one happens to form a right angle, so the height and side A happen to be the same measurement in this one. I'm not real crazy that this is the example they started with, but it's what we have to work with, so let's move on from there. So to substitute in the side B times the height, or it's the base times the height, truly in this one. So we have 4 times the height is 3, plus side A, which we know is 4. You could even do this. A is 3, B is 4, C equals 5, the width is 11, and the height in this one is 3. Okay, so side A times the width, so side A is 3, and my width. So when I do side A and the width, I'm really getting the measurement of this back rectangle here. And the net that's unfolded, well, it's a little bit harder to see in that net. I really don't like this example for this reason. We normally think of things unfolding kind of from this top edge, but they didn't in this one. They folded from kind of one side and kept on going. So I think I'm going to skip this for right now and just focus on here. So A times the width is 3 times 11 plus B times the width, so B is 4 times 11 plus side C, 5 times 11. So the surface area equals, so when I multiply those out, I have 12 plus 33 plus 44 plus 55. So when I add those all together, let's see, let me kind of condense this some here to make it a little bit easier. So here we have 45 plus, and if we add these two together, 99. Well, that's just one less than 100. So if it was 100, I'd have to go one less here. So it's 144 square centimeters, or centimeters squared. Okay, pause if you need to. Make sure you get that written down. Okay, so then when we look at this triangular pyramid, I'm sorry, it is a square pyramid. This base is a square. It has 4 triangles that come off of it. It is a square pyramid. Okay. Just going to kind of separate that. So if we look at the area of the base, knowing it's a square, we see that both sides of the square are the same. So the area of the square is side squared. So that area is 8 squared. And 8 squared means 8 times 8, not 8 times 2. 8 times 8 is 64. So this square is 64. On my 3D model, it would be this bottom part right here, 64, down here on the bottom, the base, kind of right across there. Now, each of the triangles. We need to use the information given in this 3D model to help us figure out the height. So as the triangles are unfolded, and in the definition we had in the last video, it told us that the height is the slant height from the vertex to the midpoint of the base. So that would end up being here. It's showing us that it's 10. So the area of a triangle, we have area as half of the base times the height. So we have half of 8 times the height is 10. So half of 8 is 4 times 10. So the area is 40. Now, that's just one of the triangles, but we have 4 triangles. There are 4 triangles with an area of 40 each. So I can do 40 times 4 to get 160. So I know my triangles total 160. My square at the bottom is 64. So I have 160 plus 64. I have 224 meters squared. If I were to put this in a formula, and some of you are pretty good at the formulas, I'm going to do 4 of the half the base times height plus the side squared. So that's how you would write the formula for it. There's 4 triangles, half of base times height times 4 plus the bottom side squared, and we end up with the same thing. Okay. I guess maybe I'll half times base is 8 times 10 plus 8 squared. Half of 8 is 4. 4 times 10 is 40. 8 squared is 64. 4 times 40 is 160 plus 64, 224. Oh, I said 24 and wrote a 2. 224, same thing. Okay, moving on. So it says draw a net to represent each solid figure. Okay, so it's a pyramid and it looks like it has a square as the base. Sketch out a square, and then there's going to be a triangle coming off of each side. It looks like the base of each triangle is 6, so that's going to be the measurement inside here. And the slant height is 9, so the height of each of these is 9. It says then calculate the surface area. So I need 4 of the triangles. And I have to do the side squared for the square itself. All right, so the base of the triangle is right here, 6. So 4 of half times 6 times the height, just the slant height, 9. Not a fan of this pencil. Plus the square, this is the base of the square, so this is the base, the square. I had that whole thing out of the view of the camera. I'm so used to cutting off the bottom, and now I cut off the top. That makes me sad. I'm so sorry. I'm just going to stop talking for a moment, give you time to write this down, and I guess I will talk through it once again. So 4 of the triangle formula, because there's 4 triangles, half of the base times height, plus then we need the base itself, and the base is a square. So we have 4 triangles plus the base, which is a square. So area of 4 triangles plus the area of the base. So the base of the triangles is 6, the height is 9. So 4 times half of 6 times 9 plus the side squared, because in formula for area of a square is that side squared. The sides of the triangle or the square are 6, so we have 6 squared. So 4 times half of 6 is 3, and 3 times 9 is 27, plus 6 squared, 6 times 6, 36. 4 times 27, I'll do that over here. 4 times 7 is 28. Carry a 2. 4 times 2 is 8 plus 2 is 108 plus 36. Going to add the 36 right under here. 14 or 144 centimeters squared. Okay, so then here's another example of a triangular prism. This one was a square pyramid. So in the triangular prism, I like to unfold from the base when I do my drawings or my nets. So if that's the base, I know the triangles from the sides are going to come off of it. And then I picture opening it up here. So I would have this side and this side. And technically all of these rectangles should be the same length in this one. Okay. Okay, so if I label my diagram, remember we're labeling it. Remember surface area. I'm going to flip back over here. Remember surface area for a triangular prism is side B times the height plus A times width plus B times width plus C times width. So I'm going to write that down. So my surface area is B times the height plus A times the width plus B times the width plus C times the width. So, and in the PSSA picture, they show us the sides are here of the triangle. Just going to outline the sides of the triangle, 3 different colors. Call this C, this A, and this one B. And then if we label the height, the height is 8. And then the width is what goes back here at 15. Okay, so I'm going to put my numbers in here. So side A here isn't labeled, but I know it's also part of this rectangle, and it is labeled back here. So A is 10, B is 12, C is 10. So boys and girls, I know this is an equilateral triangle. The 2 sides are both 10. And then the width is 15. And the height is 8. So now let's just substitute in. Identifying that's the hardest part. Substituting it in is pretty easy. So the surface area equals B is 12 times the height of 8 plus 10 times the width, A times W, B times W, so 12 times the width is 15, plus C is 10 times the width of 15. So 12 times 8 is 96, plus 10 times 15 is 150, plus 12 times 15, that's going to be 2 more groups of 15 than the 10 is, so 2 groups of 15 is 30, so that's going to be 180, plus, and then we have 10 and 15 again at 150. So if we add these together, we get 300 plus 180 is 480 plus 96 from here. So our surface area is 576 centimeters squared. Okay, now they're giving us a real world example, which I actually like this one. Ashish designs his own two-person tents. He sketches the dimensions of the tent as shown. If Ashish wants a tent to have a height of 4 feet, how much material will make up the surface of the tent? The tent will have material on the bottom. So we're counting the bottom of it. Draw a net of the tent and label its measurements. And then calculate the surface area. So the 6 feet this way and 7 back this way is showing us what the base of the tent is. So that's 6 feet and 7 feet. And then I'm actually going to put this right here. And then we have the front of the tent here, which is the triangle, and then again here in the back. And he said he wants this height to be 4, the height of the tent to be 4. So that's going to be right here. Oh, that green does not show up there. This is the 4, so that'll be here. And then if we unfold the tent from the top down, we would have this side wall here and the side wall here. This is showing us that that side wall is 5. So this one would be 5 as well. Okay, there we go. And then calculate the surface area of the tent. So if our tent has the 3 sides, A, B, and C, the sides of our tent are here and here, which end up being here because they fold up and attach to this side, right? So this is the fabric that comes unhooked from here. So these are the same. This is the same as this. So the sides of our tent are 5. So that's our A and C. And then B's down here at the bottom. The 6 is our height. I'm sorry, the 4 is our height. Height is 4. The 6 is our B. That's the length of the bottom part of the triangle. And then our width is here at 7. So I'm going to put it here. A is 5. B is 6. C is 5. The width is 7 and the height is 4. So then using my formula, surface area equals base time or B times the height, which is the base of the triangle. I always want to say base, and it is the base of the triangle. B times the height. So we have 6 times 4 plus A times the width. So that would give us this 5 times 7. So the A times the W gives us this panel right here. I'm going to draw that in here. That's A times W. So we have 5 times 7. B times W, that's the base of this times the width. So here's our B times W. So we have 6 times 7 plus our C times W, which is here. And that is 5 times 7. So our 6 times 4 is our triangles. So our base times the height is here and here. Our triangle formula is half the base times height. They only have base times height because there's two of them. If I do half of one, I just then have to put another one in or multiply it by 2. So the formula just eliminates that, which means there's two triangles here. So multiplying out 24 plus 35 plus 42 plus 35. Okay, and let's add those up. 24 plus 35 is 59, plus 42 plus 35 is 77, and 77 plus 59 is 136 feet squared. And that's where we're going to end this video. We'll see you for activity 4 in the next.